Welcome to this session titled ArcGIS Indoors, Developing Indoors Mapping Apps. My name is Jason Hine, and I'm one of the product engineers on the ArcGIS Indoors team at Esri. Here's our agenda for this session. After a brief overview of what ArcGIS Indoors is and why organizations are keen to use it, we'll spend a few minutes getting cozy with a few key aspects of the ArcGIS Indoors Information Model before diving into some code. Between demos, we'll look at some app development strategies that can help you achieve greater success with less effort, and we'll reserve time at the end for a quick wrap-up. So let's get started with a quick overview of ArcGIS Indoors. ArcGIS Indoors is a complete system for assembling, managing, and sharing indoors location information for a broad range of stakeholders and use cases. ArcGIS Indoors includes geoprocessing tools we can use to import CAD data, generate indoor travel networks, configure indoor positioning systems, and more. ArcGIS Indoors is powered by and delivered through an ArcGIS Enterprise portal, and we can integrate third-party tools and data to support work order management, asset tracking, emergency response, and other critical business workflows. You can visit Esri.com to learn more about ArcGIS Indoors. Now, this is a technical session, so let's get right into the tech. The ArcGIS Indoors Information Model is designed to accommodate all kinds of indoors data and scenarios in which that data might be used. We could spend hours exploring it, but our time is limited, so instead we'll take about 10 minutes to focus on a few aspects that will be important for pretty much any kind of indoors app development. Let's start with a look at the structure. The Indoors model is set up within a file or enterprise geodatabase and is largely comprised of two feature datasets. The Indoors dataset houses spatial information about your indoor spaces, organized into various feature classes. Some of these feature classes are part of a hierarchy that we'll look at in a moment. The network dataset, as you might guess, contains walkable and wheelchair-accessible indoors transportation network data. This dataset supports point-to-point routing, turn-by-turn directions, travel time estimates, and other network analyses. These feature datasets get populated using indoors map authoring tools and workflows that we won't be covering in this session. For those interested, at the end of the session, there will be a link to a series of ArcGIS Indoors webinar recordings that cover the indoors map authoring process and tools in detail. As developers, it's more important to know what feature classes are present, what they contain, and how they relate to each other. So let's take a deeper look. Just as continents, countries, states, cities, and zip codes form a geospatial hierarchy across a range of scales, the Indoors dataset's feature classes form a geospatial hierarchy that's appropriate when working with indoor data. From a developer's perspective, knowing this hierarchy is key when you want to programmatically locate and use specific indoors data. Most of these feature classes correspond to bits of information you might find in directions for locating someone or something on a campus. In college, I resided on the Colorado State University main campus in Ellis Hall on the second floor, and I've forgotten the dormitory room number, but it doesn't really matter since Ellis Hall was demolished in 2005. In addition to the 4 feature classes in the hierarchy, the Indoors feature dataset also includes a details feature class for architectural details like furniture, windows, lights, and so on. There's also a points of interest feature class for people, places, and things that users might want to find, such as exits, water fountains, restrooms, and so on. Indoors data may also include points of interest for things that are outside, such as parking meters and mail drops. Full disclosure, if you look in the documentation, you'll find there are a few additional feature classes in the Indoors dataset that aren't listed here. For example, there's an events feature class used to manage things happening in a specific location during a specific time. The thing to know is that all the feature classes in the Indoors model make use of this hierarchy to define the relationships between locations at different scales across an organization. The Indoors model defines these relationships with the cardinality shown here. Each feature in the Sites feature class relates to one or more features in the Facilities feature class. Conversely, each feature in the Facilities feature class relates to one and only one feature in the Sites feature class. The same is true for the rest of the feature classes in the hierarchy. These relationships are maintained through the use of ID attribute fields that serve as primary and foreign keys. The primary key for each feature class is named after that feature class. Site ID for sites, Facility ID for facilities, and so on. Each feature class also contains foreign keys for the feature classes that are above it in the hierarchy, so that the Facilities feature class also has a Site ID field. The Levels feature class has Facility ID and Site ID fields, and so on. These keys are used throughout the Indoors model, including in the Details and Points of Interest feature classes. With this approach, we have keys we can use to quickly and efficiently relate any feature to any other feature anywhere in the hierarchy. In addition to the ID fields, the Indoors model provides other attributes we can use to identify features, such as these name fields. The values in these fields are well suited for display as labels, in pop-ups, or in other UI elements. Some Indoors feature classes will have additional name and subtitle fields, and these fields are there to satisfy specific Indoors client app requirements. The Indoors model includes numeric fields for identifying floors by number. The level number field is specific to a facility and that facility's conventions. For example, tall buildings may not have a 13th floor, as some people consider that an unlucky number. And here's an elevator panel in a Shanghai apartment building that, in addition to missing 13, has no 4 or 14, because in Chinese, the pronunciation of the word 4 is very similar to the word death. Because level numbering can vary, when we want to do something like figure out how many floors there are between two features, the field to use is the vertical order field. Values in this field will start at 0 for the floor at ground level, with positive numbers for floors above ground and negative numbers for floors below ground. More importantly, these values are ordinal, which means we can trust them to progress consecutively without any skipping. The Units feature class has a use type attribute you can use for labeling and symbology. In this screenshot, all of the units with a use type of conference room are colored purple, making it easy to see where the conference rooms are on each floor. The Details feature class also has a use type attribute, but the Points of Interest feature class handles things a bit differently. It has category type and category subtype attributes that organize the points of interest in the client app's Explore view. We'll talk more about the configurable ArcGIS Indoors client apps in a bit. Now, as mentioned earlier, there are other feature classes and attributes in the Indoors model that you may want to use in specific scenarios. We've focused here on the feature classes and fields that you're likely to need when coding against the Indoors model for almost any kind of app. Before we move on to look at how to access the information stored in the Indoors model in our code, let's look at some examples of things we might want our application to do and see if we can figure out where that information resides in the Indoors model. Suppose we want the app to let the user select a floor from a spinner control. Which Indoors Model feature class contains that information? If you said the Levels feature class, give yourself 1,000,000 points. What if the app needs to show the user where furniture and buildings features are located? If you said Details, you get a virtual high five. How about indicating the full extent of the organization's campus? For this one, the Sites is right. To have the app get a list of conference rooms in the building, we would look at which feature class? You know, it's Units. What if we want the app to show users where the AEDs are located on campus? If you said Points of Interest, well done you. Now, this last one's tricky. What if we want to give the app an office number and have it tell us the total square footage of the building in which that office is located? The square footage of the building is in the Facilities feature class, but the office numbers are in the Units feature class. Many kinds of app functionality require relating features in one of the Indoors feature classes to features in a different feature class. Okay, it's time to take a look at some code and see how to make use of what we've learned about the Indoors model. The first app we're going to look at is a web app. Starting with one of the ArcGIS API for JavaScript samples, we're going to access an existing Indoors web map, then use our knowledge of the Indoors model to find and zoom to a specific building. After that's working, we'll take a look at an open source widget designed to work with Indoors maps. Let's look at what's involved in accessing and using Indoors data in an app. Starting with this ArcGIS API for JavaScript 4 sample app, we're going to access an existing Indoors web map, then use our knowledge of the Indoors model to find and zoom to a specific building. Nothing fancy, but what we want to pay attention to are the coding patterns used, as we would use the same coding patterns when developing other, more involved functionality. I've already copied and pasted the code from the load a basic web map sample into a new index.html file. The sample uses a web map from arcgis.com, so the first thing we need to do is get the sample connected to the enterprise portal hosting the Indoors web map. Let's add the required modules and aliases, then replace this comment and code with the code needed to connect to the portal. Connecting to the portal can take a moment or two, so we'll use a promise pattern to wait until the portal is ready before we do anything else. I think most programming languages have a promise pattern these days. If this looks unfamiliar, ask your favorite search engine, but basically, promises are a handy way to achieve asynchronous execution of our code. Once we're connected, we can construct an instance of the web map using its portal ID. We can then use the web map to construct a map view. Now, this sample already has a div to contain the map view, so we'll go ahead and use that. At this point, we should be able to run the app and see the Indoors web map. First, we'll get rid of this other bit of sample code and then check out our app in the browser. Okay. Here we have buildings on the Esri Redlands campus. Our next task is to make the app find and zoom to a specific building. This is where our understanding of the Indoors model will start to come in handy. Do you recall which Indoors model feature class has the info we'll want to use for this task? That info would be in the Facilities feature class. Now the web map has to finish loading before we can work with its layers, so again we'll use the promise pattern to wait until the web map is ready before we continue. Okay, so an organization can choose to share an indoors web map that contains a map service, a feature service, or a scene service, each with multiple sublayers. The indoors web map can also include a base map and other layers, so how do we find the facilities layer? There are a few different ways we could do this, but let's use an approach that doesn't depend on the number or order of layers in the map. This approach involves looping through and checking the properties of all the layers in the map, which means we'll use another promise pattern to wait until all the layers have finished loading before we try to check their properties. When that promise.all resolves, we'll continue with the next then in the chain. And at this point, let's also add a catch at the end to help us troubleshoot any errors that might occur anywhere along the chain. Okay, we're ready to start digging through our web map to find the facilities layer. We start by looping through the layers in the web map and checking each layer's title. It's unlikely that the facilities layer would be present as a separate layer in the web map, but it could happen. What's more likely is that the facilities layer is present as a sublayer in a map service or feature service-based layer, so we'll also check the titles of any sublayers. Let's uncomment this log message and see if our code is finding the facilities layer. Great. So at this point, all we need to do is query the facilities layer to get the feature of interest, then use that feature to set the map's extent. Performing a query requires a couple more modules. There we go. For the query, we need to get back the feature's geometry, and we'll use our understanding of the indoors model and query the name field here. As a thought exercise, consider what we might want to do here if we wanted to let the user choose from a list of all the facilities. What if we only want that list to include just the facilities on the same site as building Q? To finish the task at hand, we'll go ahead and execute our query, then process the results to get the building Q feature, get its extent, and use that extent to set the map view's extent. Let's try it out. There we go. Now that we've seen some basic coding patterns for accessing and finding information in an indoors web map, let's look at an easier way to add indoors map display and navigation functionality to our web apps. GitHub.com/Esri hosts a large collection of open source development tools and resources. If you haven't browsed through it yet, you should. Let's search for the floor filter widget by name. Here it is. The README says this widget provides an intuitive way to pick and view indoors data for a particular facility and level. The widget should work with our JavaScript API 4.x sample app and our indoors map, so let's try it out. I've already followed the instructions to download and unzip the repo, and I've copied the floor filter folder into the same folder as our web app. According to the instructions in the README, the next step is to find the last link tag that references an Esri CSS, and below that, put another link tag to reference the floor filter widget's CSS. We also need to reference the floor filter folder. The example in the README had a piece of script that will look for the floor filter folder in the same relative location as the example HTML file. Let's copy that code, find the place in our app where the ArcGIS API for JavaScript is being referenced, and paste the code right above that. The next step in the instructions would have us add and style a div for the widget, and you can certainly do that if you want. But for this demo, we're going to instead make use of the View UI to place a widget in a corner of the map. We'll do this in just a moment. First, though, we need to follow the last couple instructions to load the floor filter module and construct a new instance of the floor filter widget. We can now use the UI API to add the widget to the map view. Let's put it in the top right corner. If we take a look at the app in the browser, we can see the floor filter widget is here, up in the top right. We can use the widget to move from floor to floor or from one facility to another. There's more this widget can do, including our second task of zooming to a specific building on startup. Let's go back to the code, comment out all the code we wrote for that second task, and add one line of configuration to the widget's constructor. Now, when we reload the app in the browser, the floor filter widget zooms to building Q. The widget has additional configuration options we could set to show a specific floor, control related click behavior, and more. Good developers are always on the lookout for ways to save time and effort. When it comes to developing an indoors mapping app, or other Esri tech-based apps for that matter, there's a workflow that can help make sure your time and effort are well spent. It's called the App Strategies workflow, and it involves 3 strategies for app development: configure, extend, and develop. Let's say you come up with an idea for the killer indoors app. You spend some time identifying requirements and are feeling ready to start on a prototype. The configure strategy says that if there's a configurable app already available that might meet at least some of the business and design requirements, try that first. Most configurable apps require very little time and effort to stand up, and even if the configurable app is obviously unacceptable for production, you'll still have something tangible to show and discuss with stakeholders. Take that feedback, update the design and requirements, and repeat. If the updated requirements can be met by changing the configurable app, great. Otherwise, it may be time to move on to the next strategy, extend. And the idea here is to use one of Esri's app builders to quickly produce a starter app, and then extend that app using APIs and widgets until the app is either acceptable for production, or it's clear that the extend strategy isn't going to work. In that case, you're looking at the third strategy, developing an app from scratch. This is the most effortful strategy, but by now everybody on the team should have a clear, consistent understanding of the design and requirements for the app. And you may also find you can repurpose some of the code created during the extend strategy. So that's the workflow, made possible because Esri provides a large collection of configurable apps, several app builders, and dozens of reusable widgets. Let's take a quick look at what's available for an indoors app. For the first strategy, Esri provides a configurable ArcGIS Indoors web app that will appear in the list of web app templates for an ArcGIS Indoors licensed portal. This configurable app includes support for 2D and 3D, point-to-point routing with directions, closest to me analysis, custom branding, third-party app integration, and more. The app is built on JavaScript API 4.x, and the code has been minimized for faster loading over low bandwidth connections. When it comes to the extend strategy, you have lots of options for places to start. Take a look at the other configurable app templates, or use one of Esri's app builders to create a starter app that you can then extend with widgets, including the floor filter widget we saw a little while ago. A lot of widgets out there are open source, so if a widget doesn't do quite what you need, make it better and consider sharing your work back to the GIS developer community. To be successful with the develop strategy, use available SDKs, APIs, frameworks, reusable code such as widgets, and any other available resources to speed development and minimize wheel reinventing. Be sure to check out the other Dev Summit presentations to learn tips and tricks to make the most of your development efforts. Okay, so now let's take a quick look at what's involved in developing a native indoors mapping app for Android. The ArcGIS Runtime SDK for Android includes a mobile map search and route sample, and we're going to use that as our starting point. This sample can automatically detect and use the network dataset included in the mobile map package, so we should be able to do some simple indoor routing with this sample. I've already taken the same indoors map we were using in the web app, shared it as a mobile map package, and copied it to this virtual devices downloads folder. The first thing we need to do is tell the app where the MMPK is stored. Let's make a separate little function for this right here next to the sample's existing build MMPK path function. By making a separate function, we can easily go back to the sample's original function if we want to. Now we just need to call our build indoors MMPK path function instead of the original, and we should be able to run the sample and see our map. There we go. If we zoom in, we can see the individual units. Now you can kind of tell that we're seeing overlapping floors of indoors data here. To make the app show us just a single level at a time, we can set definition expressions on the relevant layers. In these definition expressions, we'll use the vertical order field to filter out all but the ground floor of each building. What vertical order field value represents the ground floor? That's right, the answer is 0. Let's start by defining a function named showLevel that has a vertical order parameter. We'll call this function after we've called loadMap. All right. The first thing we need to do in our function is get a reference to the map. Our mobile map package only has one map in it, so we'll get the map at index 0. Next, let's get the list of operational layers from that map. This list will include the indoors model feature layers we discussed earlier, so the next thing we need to do is loop through all the operational layers, and we just want to work with the ones that are feature layers. And we need to cast these to feature layers so we can access the methods and properties available with that class. Before we attempt to access those methods and properties, though, we need to make sure the layers are loaded. Once the layers are loaded, we can get a list of the feature layer's attribute fields, and we can then get the names of those fields as a list of strings, and check the list to see if it includes a field named vertical order. If it does, we can apply our definition expression to the layer. Let's run this and see what we get. Zooming in. Now when we get down to looking at a single building, we can see we're looking at the first floor, the ground level floor, units in this building. If we wanted to, we could go back, change the vertical order value that we're passing in to a different level, a different floor, and rerun the application. I'll leave it up to you to consider how you would present the user with an option or a control to let them pick the floor. All right, let's do a quick wrap-up. In this session, we took a look at the ArcGIS Indoors Information Model with a focus on the aspects most relevant to app development. We also saw the coding patterns for adding an indoors map and using indoors data in web and native apps. We learned a workflow for efficient ArcGIS Indoors app development, and we discovered the floor filter widget. You can use the links on this slide to learn more, and the last link here goes to that webinar series I mentioned, which covers many more topics related to ArcGIS Indoors. Thanks for watching.